we're going to talk about for about half an hour is what it's doing to the industry. We had a little conversation outside. I know where you guys are from. Where are you from?
KPN.
KPN. I guarantee KPN will be an adopter because they're a major telco. They're moving into the OpenStack environment, and you're going to do what all the rest of the world's telcos have done. I guarantee. I'll tell you a story about some of the world's telcos. So let's talk about it. This is me. I'm just a volunteer into this. I started volunteering my time, and now the OCP pay my expenses to go around Europe and tell people about it. Because I'm passionate about open source. And I'm passionate because I spent many years selling Cisco routers, running IGRP and locking the customers in and screwing them to the floor. So I feel now in my older life that I feel a bit guilty about it. So I'm giving something back to the open source community. These two guys do Cisco. They're Dimension Data guys. What is it? This is basically what it is. It's effectively, it's Linux. It's the Linux Foundation for hardware. Linux Foundation started in 2000. This started in 2011. Now, why did it start? It started because Facebook didn't like what the big manufacturers were making. They didn't like the Dell servers, didn't like the HP servers, didn't like the Cisco stuff. They didn't like being locked in. So they just went off to Taiwan and designed their own servers. And then once they'd done that, they just open sourced it. Because if you open source, you get a big community that assists, and you commoditize the hardware and you get higher volumes. And when you get the higher volumes, the unit buy price goes down. So there's a real kind of good commercial reason behind it. Good commercial reason. But some of the members in the foundation, you might not even know any of them. But let me point two of them out, because Delta, who are part of it, they own the Agema switch technology. These are the two platinum members here. There's another one. They make these particular servers. There's a few more. People have got no idea on the scale of this business. This company here, and this is the thing, all the big brands that you know and love, the big Ciscos and HPs, they don't make anything anyway. It's these guys that make all the gear. I think I'm right in saying that Delta probably make 50% of all the power supplies in every server in the world, that kind of scale. In terms of the fans, they make a very large part of the fans. They're a huge organisation on a scale that you've never seen. And when they do product, they open source it. Because they know that nobody can compete with them in terms of their manufacturing excellence. You just can't compete with them. But consequently, the end user gets a very, very good quality, extremely low cost product at the end of the day. These are a few other members. And these are community members. Now, what's interesting about this, how it's changing, is the OCP membership, up until 2015, took 4 years to get to 88 members. And you didn't have to pay to be a community member. It was free. Then they brought in 2016 membership, but what kind of happened, this technology started to migrate out of the hyperscale data centers, got adopted by the world's telcos in 2016. This is all very new. And the membership, since last year, has gone up to over 200 members. And the thing is today, to be a member, the cheapest membership is $1,000. When it was free, it only got 88 members. So there's something really special happening. And what's happening is this. It's to do with the migration of disruptive information technology. And if you read this book, it will kind of explain what's going on. Up until that point in 2016, we had these leading-edge innovators. Then you get these early adopters. And then you get this chasm occurs. And here you've got the early majority. And what's happened just in the last year, this technology, this open source technology, jumped into this big group here. And it's exploding. I was in Paris last week, and there's someone who's selling OCP gear down there. It's a tiny firm. They employ 13 people. They're selling 800 servers a week. By next year, they're going to be selling 2,000 OCP servers a week. They're trying to get a new warehouse facility with 15,000 square meters of space, 20 kilometers south of Paris. And all this stuff is going into the enterprises. So we're just coming to this early phase here. Read that book. Within the foundation, this is the way it's organized. We have the data center groups, data center project storage server. We have about 2,000 people involved in open source technologies in this. It's huge. You develop a product, you push it up to the project leads, they push it through the incubation committee, they vote on it, it gets accepted, you have to give over all the intellectual property, and then it gets published on the website. That's how it works. Anybody can make it. It truly is open source. It's lovely. There's certain technology principles that we follow. Efficiency. This server here, this two-socket server, if you compared that to a two-socket server running the same CPUs, a traditional one, this one would use 30% less energy. There's an obsession to do with efficiency. Energy efficiency. It must be toolless. All these green touch points. You don't have any tools. I can change any component on that in less than 3 minutes. It's a condition. This is what makes it really special. How long does it take to take all the screws out of the top of a server years ago? There'd be 15 screws in there. It'd take you 10 minutes just to take the top off. Very, very different. Must be open source. Yeah? And it must have gains. It must be better than what went before. Within the kind of the principles of the foundation, you can't build anything that takes you backwards. It must always take you forwards. So they're the principles that we work to. And that's how the system works. Member makes a contribution, you review it, gets accepted, and it's posted. So if you go on their website, on the OCP website, you can see all this gear. You can download all the documents, you can make your own gear if you want to. This is a very good embedded video, which I'm not going to run. This is one of the founders of the foundation, Frank Fikowski. He's one of the 6 guys that started it back in 2011. And if anybody wants these slides, they're all open source, yeah? Put your card down and I'll make sure you get the actual PowerPoint slides, and I want you to use them. If you believe what I believe, you'll go out and tell other people. Now, this is all about the end of patents. And people don't realize what's happening in the world at the macroeconomic level. There are no patents on Tesla cars. There's something really profound happening in the world. And one thing that happens when you get open source communities, they just do things better, much, much faster. Now, you guys are into switching technologies. Let me give you an example. The OCP community developed a switch called a wedge switch and a 6-pack switch. And from the point it was an idea when someone threw the idea into the community to the point when they were consuming tens of thousands of switches took 3.5 months. Now, this is a high-end 100 gig Ethernet switch. And it's got a lot more sophistication in it than your old-fashioned switch. It's actually got microservers in it as well. And it took 3.5 months from the idea to being consumed. Now, if you take an equivalent Cisco switch, that's 3 years. And the difference is because when you're doing it in a closed community, 6 guys in a room, compared to all these thousands of people that want to contribute, you just do things better and faster. And that switch, by the way, is 1/5 of the price of the Cisco equivalent. It's 80% less money. So, understand what's going on in the wide world. Read these books and then you'll understand. I'm not going to go into it, but there's a lot behind this. It's more than the technology. There's a whole kind of big change that's occurring. Really big change that's happening in the world. And it's really enlightening. This is something I got from the museum in America, in the computer museum, and this is the early software engineers. When they were locked into a DEC computer, and the only people that could write the software was DEC. Well, they said, we're not having this, we're going to write our own. So they came up with this idea, and this is how the community all kind of started in software. And exactly the same thing's happening in hardware. But this was back in the 80s. Just to give you an idea on the growth, if you look at Linux as an operating system in a data center today it's over 90% of every server will have Linux on it. Even Microsoft's Azure cloud, it's all Linux. They don't use Windows. They don't use all this old stuff that we used to use years ago. It's all open source, Microsoft. And they have an installed base of servers that's huge. All open compute servers, by the way. If you look at what's happening when the OCP Foundation started, it started here in 2011. It's about 20% of the world's market today, and yet nobody knows about it. Because it's being absorbed into the big hyperscalers and the big telcos at such scale. And that was that kind of idea of jumping the chasm. Yeah? And as we jump the chasm like we have, and you see these small companies in France, and Circle B are going to be in a very nice position, buying lots of Tesla cars with no patents on, I would guess, for more than money. By the end of the decade, it's going to take up about 50% of the world's market. Now, that's an IDC report, but I'm seeing it. I'm actually seeing this absorption. It's rapidly growing. Prediction is by 2025, it'll be 80% of the world's market will be OCP hardware. So that's storage, servers, switches. And yet everybody sitting in this room is probably thinking, I've never heard about OCP before. It's all new to you. It's all brand new. Now, there's a trickle-down effect. It all started with the over-the-top hyperscalers who consume, by the way. If I just gave you 3 companies, say Google, Facebook, and Microsoft, every single year their annual server refresh is over 4 million servers. That's their annual refresh. Just those 3 companies, all OCP gear. The telcos were being eaten alive by the hyperscalers. They were eroding all their incomes because WhatsApp is a communications app. FaceTime is a communications. When was the last time you made an international phone call through the standard PSTN system? Just don't do it. So consequently, these guys in the telco space, they need to do something really quickly and fast in order to reduce their costs. And all they're doing is copying the hyperscalers. And you can go and see all this. There's a series of projects within the Linux Foundation, Open Called. It's a project now. And you can see exactly how the telcos of the future are just going to have an OCP data center, OpenStack, and then network function virtualization. Cisco have lost all of its business in the telco market. Cisco's business, this is coming back to you. I hope this is not all being... Is this going out live on the... Right. I'll be a bit more intimate then. These guys are very much into Cisco. Their whole organisation is into Cisco. And they are moving away from being a hardware provider because they just can't compete with what's happening. Just watch this space. And there it's bleeding into the enterprises. It just does, because it works. Just one thing about why it always wins, and this is just a cost argument, which I was trying to get out earlier. If you took an optic, a pluggable optic, and you bought it from Cisco, it'd have a little EEPROM chip on it coded. So when you plug it into a Cisco switch, providing the codes worked, it'd work. But if I took that cord, that optic, and stuck it into a Juniper switch, it wouldn't work. Well, these things here, they're not made by the big vendors that you know and love. They're made by other people, companies like Finisar, who make all this stuff. They're huge companies, you've probably never heard of them, but they make all this stuff. Now, the uncoded version of that is $1,000 less. So if you wanted a coded version, it would cost you about $1,200. An uncoded, you can knock $1,000 off. Because the big vendors are locking you in, because once you've bought the chassis, they make the money on the optic. And they do it because they're locking you in. And that's why you can't use a patch cord with two pluggable optics from Cisco and plug between a Cisco switch and a Juniper switch. You can't do it unless you actually try and fiddle the EEPROM chip and try and reprogram it. But in open source, there are no EEPROMs. There is no lock-in. You can just take any product, just stick it in. That's why it's knocking the backside out of the market. So it's huge. And it's just the cost of doing business. So why are we spending all this money making all these big companies rich when we don't need to? Let me give you one example of how it works. This is a typical 40-server rack. Traditional servers, got 41 new servers. You've got 3 top-of-rack switches. And what I'm going to do, I'm going to convert it into an OCP rack to do the same kind of IT processing. And I'm going to show you what we throw away. First thing you throw away is you throw away a couple of the top-of-rack switches. Because with OCP solutions, you don't use the out-of-band management in the same way through an Ethernet switch. It's done differently. And one of the methods they use, instead of having out-of-bound Ethernet ports on the servers, you would run a Raspberry Pi from the top of the rack and connect it to a DC busbar on the back and manage the whole of the rack on a single Ethernet port on a Raspberry Pi that costs $25. Now, you can do the numbers on how inexpensive that is compared to throwing away all the switches. It just goes on and on. Some of the other things you throw away, there are no power supplies in OCP gear. You throw them away. They're those red things. See those little orange things? They're the 40mm fans. You don't use 40mm fans in these products. And I'll explain why. So you throw them all away. So I'll throw them all away, all that goes. Now what these are the intelligent power strips in the back of a rack. You don't have those either. You just throw them away. We don't have them. We don't have all that cable spaghetti at the back of the rack because we don't interface on the back. We do it on the front and we use a lot less cable. We don't have the cooling crack unit in the room. The whole data center design is different because we're using OCP gear. Consequently, if my dinger works, this is the way you would normally cool it. The cool air goes up there like that, under the floor. This is all the cable spaghetti. You throw that away as well. And you actually throw the access floor away, because in an OCP data center, you don't use access floors. The whole design is different because of what's happened here. And these is what you're throwing away. You're throwing away all this rubbish. 2 top-of-rack switches, all the pluggable optics, 86 power supply units, 208 40mm fans, 4 AC power strips. Those 4 AC power strips, you're thrown away around about anywhere up to about $5,000 worth of gear. Those intelligent power strips are over $1,000 each. All the IC cords, you've thrown away the access floors, all the crack units. And this is what it kills. And this is why in an OCP data center, you can build them easily, build the data center facility before you put the IT kit in, you can build them at half the price. I'll show you. Now, the reason I'm doing this presentation is because what I'm trying to do is reset your intuitive mindsets. You have a condition in your head that a data center needs to look like this, like the way you see an enterprise data center, but it doesn't need to. If you can change this mindset. Why do we use 19-inch racks? I'm going to quickly flick through why we do what we do, and you'll laugh at yourself, really will, why we do what we do. The reason we use 19-inch racks is because they used to have electromechanical relays in them. And when you put electromechanical relays in and put them side by side, 19 was a good pitch to optimize the rack. That's why we use 19-inch racks. So that's the module, and there's the container. That's an old railway signalling system. That's where it was developed, and it goes back over 100 years. What do you put in a rack today? The module is, you might put these in. Now, what's interesting, that module, it's a 3.5-inch hard drive, but it's 4 inches wide. Now, if I try and put these side by side in a 19-inch rack, I only get 1, 2, 3, 4. If I just move the rail slightly wider, not make the rack any bigger, just move the rail slightly wider, I'll get 5 in. Therefore, I get 25% more hard drives in the same rack. So an OCP rack optimizes the volume better than 15%. So all that empty space you used to get in your racks, you don't have it anymore. So you get much higher density of equipment in OCP racks. But there is a drawback on this. If you fill this rack up with these, that rack's going to weigh about 1.4 ton. And this is why you don't want access floors in your data center, because it won't hold it. This makes sense. I've got a module, and then I make a container. Whereas what we've been doing is we've had this container and we're bending all this sheet metal to try and make it fit a 19-inch rack. It's bonkers, absolutely bonkers. 19 inches may not have come from the use of relays. The actual size of a medieval beehive has 19-inch pitch on it, the frame size of a beehive, so it might have come from that. But this is how stupid it all is. That's all I'm trying to do, is make the point. Now, the actual rack, it has the U size on an OCP rack slightly taller. And the reason it is to do with energy efficiency. Because if you make the rack unit slightly taller, you notice this here, it's slightly deeper than a conventional server, isn't it? Consequently, what I can do, I can put big fans in it, 80mm fans, and I can put huge heat sinks into it. And that makes it efficient for cooling. Traditionally, you'll have 40mm fans, loads of them. There's something really basic that you might have learned when you were in school called the fan cube law, and this is the law. If you halve the speed of a fan, the amount of power to spin the fan reduces by 7/8. Halve the speed, reduce the power by 7/8. It's called the fan cube law. It's just basic physics. If I use a bigger fan, I could run them a lot slower. So just to give you a comparison, the energy required to spin these two compared to that is 1/10 of that. And all I've done is change the profile of the server. And it comes back to this crazy world that we've got a 1U based on a relay, and we're squeezing a server into a 1U configuration, and it's rubbish, it's stupid. Big heat sinks. Have a look at the heat sink on here, it's huge. Big heat sinks, easy to cool it. You can run temperatures through these servers at 45 degrees. That's why you don't need the chillers anymore. And just to give you an idea on chillers, if you've got a chiller system in a data center, like a DX crack unit, like a refrigeration unit, if you turn the DX pumps off and just bring cool air through, just circulate air, you reduce the power for the cooling by 9 temps, up to 9 temps. So directly you turn the refrigeration off, you get huge savings. And in lots of data centers, up to 50% of all the data center energy is the cooling. So if I take 50% of the energy and then take 90% off, it's simple stuff. Why are the cabling interfaces on the rear of a server? Because a server, all a server is, historically, it's a desktop PC that you pushed into a rack on a shelf. That's why it's all on the back. Because it was on the back, because if it was on the front, it made the table look ugly. So you made them fall off the back of the table. Well, OCP, they don't do that anymore. So what OCP does, it takes that server, takes out the power supplies, takes out the AC inputs, takes out the outbound management, takes out 3 of the, you might have 4 operational Ethernet ports on a traditional server. You don't need that in an OCP solution, especially when you're running OpenStack, because you create resilience by this kind of virtualized state that exists above the resource. So you only have 1 port. When's the last time you plugged a keyboard, video, and mouse? So they take them all out. So there's no graphics elements in here. And all you have on the front is 1 Ethernet port on the front. If you want to put 2 on, you can do, but you don't need to. Now, it's bad for you guys because you're not going to sell many switches, because if you counted historically how many Ethernet switches, how many ports would come off that, it would be 4 operational and 1 out-of-band management. So that's bad for people who sell switches, like you guys. Why do we use access floors? We use access floors because we used to run water pipes in the floor. This is a mainframe computer room. And if you run the water pipes over the top of the mainframe, they used to leak and damage the mainframe, so you put them under the floor. It wasn't meant for cooling air. The worst way you can actually vent a computer room is to push the cooler air underneath into a warm space, because then you get no advantage of what's called air density. If the air is cool coming in under the floor and I'm pushing it into warm air, I need more fan power than if I drop it in through the top. It's called air buoyancy, which you learned when you were 14 in school. You probably learnt it when you were 6 years old, playing with a balloon in the sunshine in your backyard. And yet we do it all the wrong way round. Why do we have tight control on temperature and humidity? Humidity, because in the rooms we used to have printers. And if the humidity got too high, the paper curled and it used to jam the printers. We used to have people in the room called operators. You don't have any of this in the room. And yet you still go into a data center and you see people keeping this really tight control on humidity, which costs a fortune, because in order to humidify a room, you use these steam kettles that are like 17 kilowatts each, just to put water in. So you get 1 crack unit pushing water into the atmosphere, the other one's taking it out. Just turn them all off, you don't need them. The actual kit, this works in a range from 10% relative humidity up to 90%, so it doesn't matter. This is a traditional data center. It's got all the centralized UPS, all the chiller systems. OCP data center, you take it out. You don't need the chiller systems, you don't need the centralized UPS, just throw them away. Don't need them anymore. And then what we get down to, what we do, this is the computer room here, just here. And all we do, we embed lithium-ion cells inside the racks. It's called local energy store. So there are no centralized UPSs. Now, just to get your head around this, when you build a traditional Tier 3 data center, before you put the IT kit in, it's going to cost you roughly about $10 million per megawatt. I'm working on projects in Scandinavia where they're building 1 megawatt data centers, OCP optimized, for 25% of that. So I've got $7.5 million to put kit into the room. Yeah? I don't know why we do what we do, but there we go. Just a little bit about every single rack is different in a conventional. In an OCP data center, you standardize on the rack layouts. Let's take Facebook, for example. Facebook have millions of servers in over 100,000 racks, yet they only have 7 different types of rack configuration. If I went into your building, every single one of your racks, I'm an ex-telecoms guy, will probably be different, almost. When you get into the server rooms, when you're in the switching environments, there's standardization. But when you're in the server environments, they're very, very different. And we don't use hardware redundancy in the same way, because the idea of the OpenStack, it creates these virtual instances that can float across almost like a non-redundant fabric underneath hardware. No tools. This is just a video you can have a look at. This is a stranger that walks into a room and someone says to him, change the hard drives on this. And he just opens it up. It's a video online, and this guy just goes in and he sees these green things, he pulls them, and he goes in and he presses this green thing, and the hard drive pops up and changes it. And he's never, ever seen one of these before. Very interesting. Just an example, all serviceable from the front. And if you just get your head around this idea, because what the OCP community are doing, they're totally undermining the whole of the uptime tier ratings, because they don't use hardware redundancy in the same way. We don't care. That's the idea of OpenStack. This is the idea of taking everything and virtualizing it in instances and floating it over a resource. And it really is hard to get your head around. Is the rope necessary? I don't know, but seriously. So these are some of the things that you get, and you can go and have a look at information. CERN have used OCP gear. They show a 30% reduction in power. That one rack that I showed you, that 40-server rack at 5 kilowatts with 40 servers, if I change that to an OCP rack, based on London electricity prices, the reduction in electricity costs per year on that one rack is £5,000. So if I've got a 100-rack data center, it's £500,000 per year. And in the UK, our electricity price is going up 10% this year. Now, a 100-rack data center is as big as this room. And I'm saving £500,000 a year. Now, what I've been trying to do is reset your intuitive mindsets. I saw some smiles, and I know that if anyone smiles, I've got half chance that I've caught you. I've pulled you in a bit. You haven't smiled very much, but you guys have smiled a lot. So when someone starts to kill your baby, your idea of what a data center should be like, it's like losing a child or a wife or a partner. And your performance, you go into shock, and your performance falls down over time. And all I hope is from this presentation that I leave you. Where do you think you are on this performance cycle? Where do you think you are? Did I shock you at all? Is it new? Where do you think you are? Are you there, depressed? Let me tell you why you should be depressed, because there is an implication on what we had a very nice conversation. There's something that's going to happen, and you know it. I didn't even have to tell you. You know what's happening. And if people don't change, they're not going to get into the next decade. And if you want to see any of this stuff, this is just a little joke, and I thought the Dutch would have a sense of humour. This is Nemo with a shark. And I did that. Find Nemo. So find Menno, trademarked him. All go and see Menno. He'll tell you all about it. But that's it. So any questions, ask. Or just search for me on the internet. And I'm here to just try and change people's minds. I'm not pitching a manufacturer. I'm just the concept of open source. That's all I'm trying to get across to you. And open source is better for everybody, except the people who have got the control, the people who have been screwing your company for years. That's it. Well done. If you've got any questions, but I think we've only got 1 minute left. Happy?
Yeah.
Good. Was it worth coming?
Yeah.
Well done.
Yes, really worth coming.
Go and tell your...
One question about reference designs, for instance, when you want to build a new base.
Yeah.
Is it also online or you can structure you?
This is what they're trying to do. The community are currently trying to get the reference designs out, but it's all based on volunteers, and there's a project happening at the moment. You'll start to see them coming out in November time.
Okay.
But if, in the meantime, if you get stuck, contact me, contact these guys, anybody in the community, and we've got a lot of the draft material, but it's not been published yet.
Okay.
Happy? Good, thank you.